Okay, next kind of graph we're going to talk about is a time series graph showing how some variable changes over time from one day to the next, 1 hour to the next, 1 year to the next. Here's an example showing how the average price of a gallon of gas in the United States has changed over the past year. So 1 year ago, on May 26th of 2019, the average price of a gallon of gas in the United States was up around $2.83 a gallon. And then it went down, came back up, and it stayed right around $2.62 for quite a while, like through much of the last half of 2019. And then relatively recently, it went way down. And then recently it started to come back up a little, but it's still way below where it was last year. So as you follow along from left to right, and you see how the graph goes down or up or stays pretty level, that shows how whatever it is the graph is about, in this case, the price of a gallon of gas, has gone down or up or stayed level over time. This example is just over the last 3 months, but it's comparing the average price of a gallon of gas in the state of Illinois, which is the blue line, so that's for the whole state, compared to the red line is Chicago, and the green line is Peoria. And usually when I do this and I compare those three things, Peoria is lower than the statewide average. But for the past 3 months, looks like it's been higher. Higher than the statewide average, but still not nearly as high as Chicago. And then in the last few months, I've been seeing a lot of graphs like this showing over the past month or two or whatever, from day to day, what has happened to the total number of coronavirus cases, or the number of active infections, or things like that related to the coronavirus spread. So whenever you see something like that, that's shown how something related to coronavirus has changed from one day to the next, you're looking at a time series graph. So let's draw one for ourselves. This is one that I stole out of the book. This set of data shows the high school dropout rate for students for the years 2003 to 2009. So for each one of those years, we have what percent of students dropped out of high school. So to draw a time series graph, make sure you have the time, in this case the year, on the horizontal axis. That's running across the bottom of the graph. So you can label it with the years. Make sure you have 2003 through 2009. We're not going to put points for 2002 or 2010, but they're just on there. And then for something like this, we don't necessarily have to start at 0 at the bottom, but we do need a consistent scale. So 1 square on the graph paper should mean the same amount of increase no matter where we are. 7.0 to 7.5 to 8.0 to 8.5 and so on. And we need to have room to show all our data points. So now we're actually going to show the data point. So the first data point is above 2003. We go up to a height of 9.9. And the way I've got this labeled, it's between 9.5 and 10.0. It's just a little below 10.0. Then the next data point is for 2004, and it goes up to 10.3. And we can go ahead and connect those, draw a line segment from one to the next. Then the next data point would be, if we go up above 2005, up to a height of 9.4. And then put the rest of them in, and here's what it looks like. And so it looks like, for the most part, the high school dropout rate has been going down, but there have been a couple of years when it went up a bit compared to the previous year. Now, if you wanted to do this using Excel, here's how that would look. So here I am in Excel. I've gone ahead and entered the data values, the years in the first column, and the corresponding percent in the second column. And you know what? Let me go ahead and label these, put a heading at each column. So this is the year, and this is the dropout rate. And now I'm going to select all my data and go up to Insert and click on not this, not the line chart, but this. And I don't want just the dots, I want the dots that are connected. And so there's my time series graph. Looks pretty good, pretty much how we like it. It did start at 0 and went up from there. So we could change that. There are ways of adjusting the characteristics of the graph so that you don't start from 0, or so that you add labels to the axes, or various things that you can do to change how the graph looks. Next kind of graph we're going to talk about is a pie chart, also known as a pie graph or a circle graph, because it's in the shape of a circle. And it's used to show relations between parts and the whole, or to show what fraction or what percentage of some total falls into each of several categories. Here, for example, is a pie chart showing for Logan County, which has been relatively unaffected by the coronavirus, showing what percentage of the people who were tested for it tested positive versus negative. You can see that way more people tested negative than positive here, fortunately. A couple other pie charts I found in the newspaper a few years ago. One I made in a previous semester about the majors that my students in my statistics class reported. Some were pre-nursing majors, some were sports management, some were business, criminal justice, exercise science, and then various other things were undecided. So for our example of actually drawing one of these, let's construct a pie chart based on the responses I got last semester. I'm not using this class because there's only 6 students, but last semester I had 25 students, and I asked them to either agree or disagree with the statement, "I like math," and here are the results. So some people strongly agree, some people strongly disagree, some were in between. Let's show this using a pie chart. And again, you can draw this yourself on paper, or you can get a computer to do it for you. If we're doing it ourselves, we are going to need to start by computing the relative frequencies as percents. We need to know what percent goes with each one of these categories. So remember how we did that. There's 25 in all. So if we take each frequency divided by 25 and then convert that to a percent, that's how we do that. So for example, for that first one, a frequency of 12%. So there I've filled in the percents for all the categories. Now we've got our percentages. We're ready to start drawing the pie graph. So draw a circle. And if you're not good at drawing circles, you could trace around a bottle cap or a jar lid or something like that. Now, if you were doing this to make it really fancy and looking exactly right, you would get yourself a protractor to measure angles, and you measure out angles that are whatever percent of 360 degrees to make each section of the graph. But nowadays, if you did want a nice professional looking, exactly accurate pie chart, you'd probably be doing it with a computer. But if you still want to do it by hand, to get a reasonably accurate looking pie graph, just that you draw by hand, here's how I would do that. I would start by just dividing the circle in half. That's fairly easy to do just by looking at it. And if any of these percents were exactly 50%, that would be half of the circle. One of these is 48%, so that's going to be a little bit less than 1/2 of the circle. But let me go ahead and divide the circle in half the other way. So now it's in quarters. So if anything was 25%, it would be 1/4 of the circle, one of these fourths. Now, none of these are exactly 25%, but one of them's 24%, so that's pretty close. It's going to be just a little bit smaller than one of these quarters. And then if we want to divide things down more than that, we can take one of these quarters and fairly easily divide it up into 5 equal pieces, kind of like this. So each one of these would be 1/5 of 25%, which is 5%. So from here to here is 5% of the circle. Here to here is 5%. Here to here is 5%. So if I want to go ahead and draw in 48%, remember I said that was a little bit less than 50%. So it was 2% less than 50%. So that's 25, 30, 35, 40, 45, and then 46, 47, 48. So this section represents the 48% of the people who answered neutral. They neither agree nor disagree with the statement, "I like math." Then, if I want to go ahead and put in the 24%, remember I said that was a little less than 25%. So that's just a little bit less than one of these quarters here. Now, if I divide this quarter up into 5 equal parts, like this, then I can see where to make 12%, because that's going to be 5, 10, and then these two that were left over here. So that's 12% there for the strongly agree section. And then the other two are both 8%. So what I have left in this section here is 5, 10, 15, 16. If I draw that and divide it exactly in half, like that, then each half would be 8%. Now let's see what this would look like if I did it with, say, Excel. Okay, so I've gone ahead and typed in all my data, my 5 categories, and then the frequency for each one. I don't have to tell Excel what the percentages are. It's going to figure that out. But I'm going to select all my data, go up to Insert, and insert a pie chart, just the first one there. And here it's constructed it to be color-coded, but I want it to label the sections directly and put the parentheses on them. So under Quick Layout, I'm just going to pick the first one there, and it's going to look like that. And then, of course, I could change the title. There's other things I could do to change the way the graph looks. We'll talk about some of that when we get into the project, but there's my computer-generated pie chart. I have a little bit more to say about pie charts, and then at least one other kind of chart we're going to talk about, but I'll come back and say all that in part 3, the next video.